Hopefully you've taken just a moment to get over the incredible frustration of the end of the last video. What I'm going to introduce is known as the direct substitution property. The direct substitution property says that if you are given a limit, try plugging in what x is approaching. If it happens to work out okay, if there are no domain issues, then chances are pretty good that's what the value of the limit is supposed to be. So we're going to say let p and q be polynomial functions. Now a polynomial will contain powers, constant multiples, sums, and differences. We have limit laws for all four of those things. A rational function introduces a division, and we have a quotient law for that. So the direct substitution property says that if you're taking the limit as x approaches a of a polynomial function, try just plugging in what that x value is. If it works, which it always will for a polynomial function, their domain is always all real numbers, then it's going to work out. Similarly, if I take the limit as x approaches a of p of x divided by q of x, then I can simply plug this in. Now the one caveat of the quotient property is that q of a is not allowed to be equal to 0. If it is equal to 0, then chances are pretty good you're going to see something else come into play. Now just to give you a quick example of what this all means, if I wanted to consider the limit as x approaches -2 of x squared plus 3x minus 4. This here is a polynomial function. X squared plus 3x minus 4 contains all of the things that I mentioned just a moment ago. It contains powers, constant multiples, sums, differences, all of those things. The direct substitution property, I should probably write that down up here as well. Direct substitution property. I'm going to refer to it as DSP for short. The direct substitution property says try plugging it in, and if you happen to get a number out of it, then you're set. I have 4 minus 6, that's going to be -6. Additionally, this will work for rational functions as well. If I say take the limit as x approaches 3 of x squared plus 2x minus 8 and put that over x plus 4. Well, that's a polynomial function divided by a polynomial function. That's the definition of a rational function. Try the direct substitution property. If it works, great, we're done. So we plug in x equals 3 wherever it's relevant. In the numerator, I am seeing 9 plus 6, that's 15, minus 8, that's 7, divided by 3 plus 4, that's 7 as well. So we get 1. If it works, great. If not, we'll try something else.